Okay, welcome back to math class, and welcome to 10-7. So in 10-6, we were talking about what a secant is and how secants and tangents intersecting inside or outside the circle affects their angle measure. Today we're going to talk about secants and tangents and how their lengths are related. Okay, so the first thing we're going to talk about is, let me draw my circle. If I have two chords that intersect inside of a circle. If you guys remember, a chord is a line segment that's inside the circle and it hits both sides of the circle. That's a chord. So if I have two chords that intersect, what I know about these two chords is that, well, first, they're splitting each other into two segments, right? So if this chord is A, B, C, D, B, E, right? So one chord is splitting another chord into two segments. This one is splitting this one into two segments. What I can know about these two chords is that the products of each length of its segment are equal to the product of the length of the other two segments. So if I took AB times BC, that would be the same as if I took DB times BE. So this segment of the chord times this segment of the chord equals this segment of this one times this segment of this one. So if I told you that this was 5 and this was 6 and this was 3, I know it's not exactly proportional, but say I said that, then what I would know was that 5 times 6 has to equal 3 times whatever AB is. So I would do 5 times 6, which is 30, equals 3 times AB, and I would divide by 3, and I would get AB equals 10. Pretty straightforward. Follow this equation. The next thing we're going to talk about today is what happens when two secants intersect outside the circle. So this is two chords intersecting inside the circle. What happens to its segments? What if I have two secants intersecting outside the circle? If you remember what a secant is, secants also go through the circle. Okay, so I have A, B, C, D, E. Okay, now with secants, you see that when they intersect outside the circle, our circle is basically dividing our secant into two segments. Now the way that we do secant segments, a segment of a secant can only have one end point that's on the circle, if that makes sense. So the two segments that we're splitting our secant into is AB, its external segment, and the whole line, or the whole from A to C to this one. So basically we have a segment from A to this edge of the circle, and we have a segment from A to this edge of the circle. So don't think of it like I split it external and internal. Think of it like the external bit and then the whole from A to C. Now if I do that, those two segments are proportional to these two. So similar to the equation we had in the previous example, I'm going to do AB, our external segment, times AC, this whole one here. That will be equal to the external segment of this one, AD, times the whole one, A to E. That has the potential to be a little bit confusing because it might be tempting to do AB times BC, but it's not. It's AB times AC, the whole thing. Now, if I was asking you, like if I said, this is 10, and the whole thing is 30, so if I said AD equals 10, AE equals 30, AB equals 15, and then I said, find BC, let me go ahead and label it 10, the whole thing is 30, AB is 15, and I'm asking you for this one. When I plug it into my equation, what I'm going to do is I'm going to say what I know, AB is 15, I don't know AC yet, AD is 10, AE is 30. Okay, so what I'm going to do is I'm going to get 300 equals 15 AC. I'm going to divide by 15 and I'm going to get AC equals 20. But what I know, AC is not this. I'm looking for BC. That's what I asked you for. So what I'm going to do is I'm going to take my AC value, which is the total, and I'm going to subtract what I know AB is. So AC minus AB equals BC. It has an extra step. So I'm going to put in 20 minus 15 equals BC equals 5. And that's my answer there. So pay attention, this is what's different about these ones from the first one. The equations look similar, but our segments of secants are different. It's an external segment and then the entire secant. External and then the whole thing. All right, one more thing we can know. So we did 2 chords, and then we did 2 secants. Now we're going to talk about what happens when a secant and a tangent intersect a circle, they go through a circle and they intersect outside the circle. So I'm going to draw my external point, my secant, and then a tangent. I'm actually going to draw it like this. Okay, so this is my A, B, C, D. Okay. When a secant and a tangent intersect outside of a circle, you'll notice we have our secant being split into 2, but our tangent is not. Because our tangent only intersects the circle at one point, it's just one line segment that we have to work with here. So what we're going to do, or what our new formula is for this, our tangent, the line segment here, A to D, squared, is going to equal AB, our external segment of our tangent, times our whole secant there. Hopefully that makes sense, because this one is not being split into two pieces. We only have we'll only have one value for our tangent. We're still going to use what we used when we had two secants. Remember, we used our external segment and the whole secant. We're still doing that. We're still doing external segment times the whole secant. But this time, instead of putting it equal to two things multiplied by each other, we're just doing AD times AD, which is AD squared. As long as you can keep straight in your head which thing is which, I think you'll be able to do this really well. But we have chords, we have secants, and we have tangents, and the rules are different for each one. So make sure you commit those to your memory before you finish this lesson.